So let us have example number 2 of adding and subtracting vectors. Suppose we have these three given vectors. Vector A, whose magnitude is 2 Newton, and it's 140 degrees from positive x-axis in counterclockwise direction. The vector B, 5 Newton, 35 degrees. And vector C, 8 Newton, 110 degrees. So we wish to look for vector C minus vector B minus vector A, which is equal to vector R. Vector R represents the sum of these vectors. So that's vector C plus the negative vector B plus the negative vector A, or vector C minus vector B minus vector A. Okay, so the first thing to do is to look for the x component of vector R. Okay. What is R of x? So C of x minus, since this is minus B of x, vector B, we have minus B of x minus A of x, since that's minus vector A. So what is this C of x? We have 8 Newton cosine of 110 degrees minus vector the x component of vector B, which is 5 Newton cosine of 35 degrees, and then minus the x component of vector A, which is the 2 Newton cosine of 140 degrees, and that is approximately equal to negative 5.30 Newton. That's R of x. Next is to look for the y component of vector R, or R of y equals C of y minus P of y minus A of y. And what is this C of y? That is the magnitude of vector C, which is 8 Newton, sine of its direction, which is 110, minus vector the y component of vector B, which is B of y, and that is minus 5 Newton sine of 35 degrees. And then the y component of vector A, which is A of y, that is minus 2 Newton sine of 140 degrees. And that is approximately equal to 3.36 Newton. So we now have the x component and the y component of vector R. As we look at the x component of vector R, that's negative 5.30, and the y component is positive 3.36. The x component is negative, the y component is positive. When we do graphical method in determining the sum of vectors, we can say that the resultant can be located in what quadrant? X is negative, y is positive. So we can locate the resultant at the second quadrant. Okay, so we have now the x component and the y component. So next thing to do is to determine the magnitude of vector R. So we have R equals the square of its x component plus the square of its y component. So that is the square root of negative 5.30 Newton quantity squared plus the square of the y component, which is 3.36 Newton 1 squared, then that's approximately equal to 6.28 Newton. Okay, so this is the magnitude of vector R. How about the direction, theta? Theta is the inverse tangent of the y component over its x component, or theta equals the inverse tangent of, what's r of y, 3.36 Newton over the x component, which is negative 5.30 Newton, and that is approximately equal to negative 32.37 degrees. Now, if you want to determine the direction of vector r from positive x-axis in counterclockwise direction, since one of the components is negative, then we will add theta by 180. If we're going to add it by 180 degrees, then direction from positive x-axis in counterclockwise direction will be 147.63 degrees. So again, if one of the components is negative, then we need to add 180 degrees to theta, so to determine the direction of vector r from positive x-axis in counterclockwise direction. Theta is equal to 147.63 degrees. So we have the magnitude as well as the direction. So vector r is equal to its magnitude, which is 6.28 Newton, comma, its direction, which is 147.63. So this is how it looks like when you use the graphical method of determining the sum of vectors. Well, here vector A, 2 Newton, 140 degrees, vector B, 5 Newton, 35 degrees, and vector C is 8 Newton, 110 degrees from positive x-axis in counterclockwise direction. So we wish to look for vector C minus vector B minus vector A equals vector R. So by component method, we found out that vector C minus vector B minus vector A is equal to 6.28 Newton, approximately 6.28 Newton, 147.63 degrees from positive x-axis. So where is this vector C? In graphical method of determining the sum of vector, we need to lay the vector one after another by placing the tail of succeeding vector to the head of the preceding vector. So here, the first vector, we have vector C. So this is vector C with magnitude 8 Newton, and it is 110 degrees from positive x-axis, and it has a magnitude of 8 Newton. And then vector C, we have vector C, vector B, vector B, 5 Newton, 35 degrees. So how come it goes at this direction? Look at here, it's a negative vector. Negative vector, it means it has the same magnitude, equal magnitude, but pointing in opposite direction. So instead of going at that direction, 35 degrees, this is positive vector B. But we have negative vector C. So it goes to the opposite direction. And then we have the last vector, vector A, which is 140 degrees. So instead of going at that direction, that's 140 degrees, that's vector A. Instead of going at that direction from, it's 140 degrees from positive x-axis, it goes to the opposite direction, at this direction. So this vector here is negative vector A. Okay, and the resultant or the sum of these three vectors, when we represent it by a line should be drawn from the tail of first vector, which is this one, vector C, up to the head of the last vector, which is negative vector A. So this is the resultant vector, vector R. And it has a magnitude or length of 6.28 units. 1 unit here is equivalent to 1 Newton. Since we cannot have 1 Newton length, because Newton is not a unit of length, rather a unit of force. So we do scaling. We have 1 Newton is equivalent to 1 unit when we graph. Or we are going to use the graphical method of determining the sum of vectors. So this is vector R, and it has a direction of 147.63 degrees from positive x-axis. 6.28.